Okay, hello class. Hope you've had a good week. Lots of good stuff to grade. So let's jump right to it. So this week you had first half of the chapter in the new book 3.5. And we want to take a look at, share the screen for, we're in your samples and examples, usual place here. Module 5, samples and examples, week 1. So lots of folks, you'll see some common names: Sharika, Calvin, Noah, James, Madeline, Phoebe, Gavin, Chris, Haley, and Grant. So on the personality match, so many people chose to do that one. There was some confusion, it seemed, though, that what we were looking for is you needed to, let's take a look at Calvin's, I think, for this one. You needed to find the angle or the dot product between these. Some people said, I think, it's a nice job on the target game for most everybody. You need to go ahead and do some calculations. So you had to put yours in, and then a lot of people were just like eyeballing, like I think mine is most similar to, and they would just look at the numerical numbers that they put in. We needed something much more quantifiable than that. Other people maybe did subtracted the two vectors. So think about why that wouldn't make sense. So maybe in R3, just shorten the vectors and think about geometrically why that doesn't make sense, right? And what we're really looking here, when you're talking about similarity of vectors, and these vectors have their information retrieval, like the search engine ones that you did, or these personality ones, we've got vectors in space. And they're going to be pointing, as long as they're pointing in the same direction, that means their dot products are very close, or you can actually get the angle. And that angle formula, remember, is built off the dot products and then just normalized by the length of vectors. But as Haley did a really nice job explaining in hers, she just looked at the dot products because, again, these vectors will then be normalized. So check out her discussion there. And let's go back and look at Noah's calculations. These on this one. So Noah's always really thorough in his explanations of what he's doing. And then, so here's his vector. Now then you actually have to do the calculations between this and every other one. Like, so he got the theta, the angle for all those with his, and he was very close on several folks, but not as much on others. So, and again, Haley's had a really nice explanation on that. Then the discussion for the personality match as to, should we be looking for people pointing the same? Should we be looking for orthogonal or in opposite directions? And then I'm showing this in R3, but it extends to R5 or n-dimensional space or anything about search engines. I really enjoyed reading those because some people were like, hey, I want someone similar to me, but maybe a little better on a couple of these traits. It shifted the angle. Several people settled on orthogonal. I think that was Madeline and James, that like, hey, this might be too much butting heads if we're opposites, and this is just like dating yourself with the same person, not very interesting. And said maybe this is the best. And one of my favorite comments from this week was Madeline's, probably I'm not an expert or anything about personality matching and matchmaking software, but she ended up with an orthogonal. Okay, then let's go back and look at the next one is the target game. I really liked James's discussion here. What shucks, did I not have James in? I'll have to add James's because he's in here for the calculations. I should have his activities as well. He just did a really nice explanation of visually how he was doing this. Like when it said, here's U and V, and it said U minus V, he went here, and then he got the, remember connecting the parallelogram. So he showed pictures of each one. It was really well done. I'll add that. And yeah, U and V, and then maybe we had 2V, it extended out here. He had the parallelogram between those two and drew it like that. So really well done of how he was mentally doing this in his head. He had the steps. Oh, and then on the search engine, most people So let's actually go to Phoebe's. So Phoebe was one of the few people that, most people did the search engine page, but they didn't do the desktop ornament, but Phoebe is one of the few people that did this. So she has like a query vector, and then you have to put other vectors in there. And the ones that are inside that, right? So if there's more, if you expand your cone of the angle of interest that you're looking at, you'll capture more vectors, but they might not be relevant, right? So we want, as we tighten that, the problem with tightening it, you're getting very relevant to your query vector, right? You're getting document vectors that are relevant. So that's good, but it might be the case that there's nothing left in there, right? So you're returning no documents related to the query because you were too tight. So you don't want to be too large, and that's a parameter you have to change when you're building one of these search engines. Okay, and then one more thing. So nice job, Phoebe, actually building that. I think they're solidifying your head. But this search engine one, I'll go back. The search engine activity where you were just ask one question at the end, are all these going to be in the non-negative octant? Let's look at Madeline and Gavin had really nice discussions. So target game, oh yeah, search engine, here we go. So search engine, and Gavin had a similar paragraph. These are, I feel like Madeline and Gavin are inventors in the class because they're the only ones that answered this way. Most everybody said, hey, how do you get a negative number when you're counting number of words? You can't have 0, 0 or 1, 2, 3, something, right? Non-negative. So it made sense in that one. So fine, I accepted that answer. But if you were, some people thought, and this is Madeline Gavin said, what would happen if you had not, like negations? Does that mean you're actually taking that and pointing in the opposite direction because you don't want anything related to that particular one? You really want to strongly pull away from that. So I thought it was really clever to think about it that way, and just to let Madeline and Gavin know, like that's actually an open question. There isn't a great solution to how to handle negation in one of these vector space model or latency index and information retrieval. And I think it was Gavin, even one of the other ones pointed out that you can use, like in Google, I don't know if you know, you put a minus sign from something that's like you're not. And so many search engines do have this feature, this capability, but how exactly they're doing it, there's a lot of hacks to it because I was a consultant for a patent infringement case against Google, Yahoo and Microsoft. I got to look under the hood of all these search engines and see what's happening. And again, they're sort of all over the place. And in the literature, even this is still, like I said, open problem. So interesting thoughts on that. Now let's go back, move on to calculations. Overall, nice job, but I did repeatedly see an issue for page 19, number 6. I think I'm just pointing out Sharika's work here. Yeah, so a lot of people did this, got to number 6, like, hey, I need some help. But we can look at the picture that Sharika started us here. And it's true that many of you did get this because this is kind of, I was a little sneaky putting it early. And if you want to check out, Calvin actually used ideas from chapter 2. So we are going to be able to solve this another way in chapter 2, but I do think you had enough now to piece pieces of it together, and about half of us did this, which is really neat. So let's just talk about how most half of the class were able to piece this together using the knowledge that they had currently. What they did was they said, okay, there's a point of intersection here. Madeline made the distinction that, hey, this point right here on the square root function is not differentiable. So even though 0, 0 is a point of intersection, let's go to the 0.11. Most of you did that. You got to the 0.11 as a point of intersection. Now, how do you get the angle of intersection? Well, what if you had tangent lines? And so some of you got this far, you went and got those tangent lines. But then how do you get the angle between two lines? Well, we haven't really learned that, but we do know angle between vectors. So you just follow the tangent line. You know what it means to have a slope of a half. So it says when I run 1 over here, I rise a half. When I run 1 over here, I rise 2 on this one because I had a slope of 2. So you actually could construct the vectors because you'd have 2 points, the 0.11, and then I went to the 0.2, 1.5, And then from here, I went from the 0.11 to the 0.23, right? So you can construct the two vectors, get a vector A and B, get the angle between them. So really nice job for doing that. Noah had some nice ideas towards that, but I think Chris and Haley had some nice work on this one too. So I'll just show those. This. Yeah, so again, here's his picture. But what I liked on this is his picture is really clear how he was getting these angles. He actually built the triangles and was like, I'm moving one over here on the square root function and I'm rising a half. And then he got the angle and did the difference. So that was neat to see that with geometry and trigonometry. And then let's go to Haley's because I thought hers was another really nice, clear explanation. Let's do calculations. Yeah, so here she is, tangent line. She got the equation. She went and got the vectors, just like we talked about, and then just plugged them into the formula. Okay, let's point out a few more on the calculations. I really like the work by Gavin, Grant, and Asher. So you should see those should be in there. And then James and Madeline both used tech tools to check their work. So James used Wolfram Alpha and Madeline used CalcPlot 3D. So let's take a look at one of those. Okay, here we go, Madeline right there. So first off, she's got here. Oh yeah, so her target practice, she was just checking the work visually, and then with CalcPlot 3D. Also, oh yeah, also did Wolfram Alpha, normalize. This one about, instead of normalizing to have length 1, you want it to have length 5. So you could normalize and multiply by 5. And that's what I liked by, I think it was Gavin and Asher had some nice comments about how they sort of did all that in their head. And, oh yeah, number 5 is points lying along 3/5 of the way. She's checking her work visually. Oh yeah, and what we just talked about was number 6. So she chose that x equals 1, got those two vectors, plugged into the formula. Okay, one last thing on Let's Go on this class software. We also had specials. So this week you had some, this was fun for me to read your module. Oh yeah, computer-based math. So here we are. Some really passionate responses to this and interesting answers. And I would recommend expanding and reading these. A few that I really enjoyed. Yeah, here's a great one by Grant. Grant made some good points about math building and math being tall and how, because it builds, you need some of this basic competency in algorithmic training, and you have to be able to do some of these calculations. So you can't just totally turn it over to computer-based math, in his opinion. And he also had a really nice discussion about learning math is patience, persistence, and dedication. And sometimes you get that through this sort of algorithmic rote practice. Many of you had came upon that it should be a mix of by hand and tech tools. Sharika, Madeline, Isabella, Phoebe, Lauren. I really encourage you to read Isabella's and Lauren's. Were nice responses on that. Some of the downsides, if you want some of both. I like Tripp's because he talked about math to him as just a series of puzzles, and think approaching it that way opens up a whole. I think you just have a much better attitude towards it. It's, hey, this is just a puzzle. I gotta be able to do this. And so he had a nice, just comparing that to computer-based math. Let's see. Oh, Kyler and Grant had some really good discussions about, yes, in the calculation part of it and doing it by hand, that handwriting, that repetition that is through handwriting helps with memory and learning. And that's absolutely true. Like what we know about the memory is just hearing something, seeing it, and then you also, usually when you're writing, like almost inaudibly speaking it. So you have these many different ways that you're imprinting that in your memory when you're doing that. And the question here is just really, many of you are talking about how much is enough. You need an amount of competency so I can do that. I can imagine if you couldn't add numbers, like you still have to go back and do it on your own tactile. So you need some competency, and maybe what is the amount that you need? This balance is striking that balance is difficult. Phoebe, Grant, and Grace all talked about, too much dependency on the computer without understanding is doing no one any good. Like you have to have, it's fine using a computer at a certain level, but you have to have that understanding behind you. And many times people get good at the calculation and don't have the understanding. So we need both. Kaylee's discussion, I really like to check out hers. It was on, she compared this to statistics education and how that's done differently than math education. And often they are using tech tools in a different way. Students, she also talked about matching this to students' own interest in the aspects of that math that they like. Some people really do like being a human calculator and take pride, and it's a puzzle to get each one, and there's a pride when you're done and you got it. And so that's true, and some students would not be as attracted to math if you just totally turned it to computer-based math because they enjoy that aspect of it. James talked about the value of computer-based math in preparing students for the workforce, because that is true. When you're working, less and less is done by hand. You need the by hand again to help you understand, to set up a solution approach, to have a problem solving, to be creative, understand how to connect the concepts. And then most of the time in the real world, especially if you're going to be an industrial mathematician, those problems are such complexity that by hand helps you on a smaller scale version of it, but when you're actually doing it, there's some numerical technique that's going to solve something, because it's thousands of variables and it's much more complex than we can do these nice little ones by hand. Calvin, Aaron, and Gavin had some nice discussions. I would encourage you to read Calvin's in particular. And it was interesting to read and try to think for each of you whether you consider this class in line with that TED Talk or in line with computer-based math, and where do we fit in that spectrum of like never being allowed, as many of you were in your future classes, never being allowed to use tech tool, to being allowed, and where are we in that spectrum, and how do you think it's helped or hindered with your education? So again, fascinating, thank you. I really appreciate reading those. Okay, so you're on to the second half of this chapter. Super fun stuff. Again, we're going to be riding along vectors along lines in R3, and the challenge problems, I think you'll have a really good time. Every semester, students really enjoy the end of this chapter. All right, we'll have a good week, and we'll see you next week.